Okay, so I'm back with a new live stream. We are continuing on the last project of this app that I'm making. Those of you who doesn't know what this is, it's just an app, something that I've been working on. I don't have a name for it, but it's just TWL. It's train while labeling. It's an app that allows you to train machine learning models while labeling the data. So yeah, so I'm just trying to make a graphical user interface which allows you to upload or select a project folder where you have a ton of images that will be this GUI will allow you to label those images, and while labeling, the specific model will be trained. So the model in question can be selected into the settings page. So the start page text is not showing. Okay, I think that the utilities, the models, and the source, these should be all in the same folder. I'm not sure, and I'm just going to keep it like this for now. For the start pages, only thing that's not working. It's this part, because it's not showing because it's not getting the start page thing. I'm not Yep. What I'm trying to do, I'll just show you what I plan on solving. Few things that I plan on solving today. First off is this. Here is, it's called start page text, but I've written something in the config file, meaning in here. This is the start page text that I want it to show, and so that is not what it's showing at the moment, as you can see. So where's the start frame? Yeah, this is the start frame. So I'm not sure if this works. Okay. Should be on the utils dot config. This should work. I'm not sure it should. Attempted relative import be on top level package. Well, this can be solved if I just put everything into the source folder. Start page text. Welcome to learning rate. Yeah, these things. Not sure why would this be here. In any case, let's just put it into the source folder. Let's move it. Yeah, move it. Let's solve it one by one, and let's move it, the models, into the source folder as well. That's going to solve basically few things. The model should not have changed the model, but yeah, what can we do? Now this will throw some errors because there are things that there are specific packages or specific files that it cannot reach. For example, if we think from the beginning, this is the app, where the app is like, all of the pages are constructed in this particular line. This is where all of the pages are constructed. And when each of the pages are constructed, they are taken from here, and this is actually not needed because the start page text is not used in here, rather it's used in here, and it cannot find it. So it should be in the now in the utils dot config dot yeah, now they should be in here. Okay, yeah. Now this should work, but there are other things which will not work. For example, let's go to settings page, and the config file is the JSON load. Yeah, here it says the models dot and here so it should be an src backward slash models.model.json. Yeah, not sure if it will work. Yeah, no model named utils in the start page text. This is confusing. src.utils.config import start. Let's see if it works. That's not a problem, but it has a problem on settings page, line number 14. No such file found in models. If I write like this, maybe should work. Okay, it does work, and hopefully, okay. If you think that, I'll just keep it on this screen. This is the model file. Let's open it up again here, and image labels are here. Okay. Okay, so what I need to change is, suppose we change this, we'll see the changes here directly. So let's say that the height and the width of a picture is 1 and the channel 3, the output node is like what, 10. And let's go to the label and see the changes in action. No, because there are problems here. No such file or directory found in the settings of the line number 53 and 63. Let's, whoa, I don't want that. Okay, let's go to the settings frame. That's 53 and 63 here. Let's write it like this, and 53 controller units and everything. Okay, let's do it like this now. Let's cut this up, and let's go to the app. Okay, let's start it with 50, and let's say it's 10, 10, 3, and 10. Let's go to label. Okay, and sorry, we did not see the changes. Yeah, there are the changes. The input is the 300 neurons because it's 10 times 10 times 3. Hidden layer is 50 neurons, and the output layer is 10. And it of course loads the images and whatnot. So the initial error has been solved. What I think we should do is rather than thinking about other features to be added in here, let's just make one thing that'll work, like, from first to last. Just let's think about the MNIST data set for now, and let's just make that work from end to end. Yeah. All right, so if I want to make this work, then I need a neural network, which means that I need means I need specific things such as PyTorch, not let me install PyTorch. I don't know how to fix the specific thing that I'm going to show you here. So it's just TWL and git install PyTorch. It's a big package. This will take a while. Okay. And initially, I thought about making the neural network by hand, meaning that using simple, um, I don't know, the NumPy packages and everything. Um, but I think that'll be too much work. Rather, I'll just make the PyTorch model according to the config, um, which will be trained in a stepwise manner. Let's just go and check one thing. Go to PyTorch. Mhm. This is not what we'll do. What we will do, we will not exactly use a PyTorch data loader, or I don't know if we should. Let's see. Oh, why did I click that? Data loaders shuffle for training and not for validation. Don't think I will create the data loaders. This uses the fashion MNIST dataset. So it still has the 28 by 28 grids, but it's not for the digits, but rather like pieces of clothing, like shoes and jackets and whatnot. We define a model. We define some loss functions and optimizers. Now the training group is what I'm interested in. Per epoch activity. So this is just train one epoch. Right. Completely forgot how it used to work. Think about it for a second. Um, Firstly, the epoch is where you put in the data. Like there are like data loaders. There are data loaders, and then you make the zero gradients for every batch and make the prediction for this batch. You make a specific prediction based on the random or zero gradients, whatever that is. So you make some certain outputs, and using the loss function above, you calculate the loss here. Okay, so this is the loss. And the backwards is the backward propagation, which takes in the partial derivatives of the weights and with respect to the losses, and then uses the step uses the what step uh forgot that's name uh, to go to take the step of reducing the or changing the gradient. Okay, so optimizer dot step and then gather data and report. This is for the reporting, but this is just these two lines going from the the forward paths, and this is the backward back propagation. This is just one instance of the training using all of the data. That's what you have to keep in mind, using all of the data. So for some specific models, if the model size is low and the data is huge, and as the data is huge, one epoch will going to take a lot of time, because the data is big, and in each epoch, I believe, yeah, in each epoch, as you can see, that the data is or the for loop is iterating through the entire data set. So so if we consider one epoch, that means in one epoch the training model will go through all of the training data, get for each iteration, for each in batches, we'll get the gradient, and then there will be a backward pass with changing the gradient again. So yeah, so that will be for all of the training data. So what we want to do here is not make it for all of the training data. Okay, as you can see here, this is the part that we need. Here's the training loader. We do not want to use a loader because the loader has all of the data in it. Okay, the PyTorch data loader is constructed so that all of the training data, so the testing data, are inside of the data loader, so that we can use the data loader class to enumerate and make it easier for the models, so that in just one go it goes through all of the data. But we are not going to use all of the data in our app. Rather, we will be using using the parts that we like. The user can choose the batch size, but if we don't want to add the feature of choosing the batch size, the model will be trained on each click. So for each of the data that's being labeled. That's not good. I know that is not good, because there are no yeah, I understand the problems, because you see, if you have the data, suppose let's bring out paint. Let's paint it away. All right. Okay. So supposingly you have the data. Suppose the data is the MNIST data set, which has the zero and all the way to the image of R9 of the MNIST data. So you have a lot of data, like 1,000 of these images, and then 1,000 of these images. So you've got like a lot of images of the image data set. Okay, so if we gather all of the data in 1 folder and then start iterating through it, that's going to be problematic for the model, because if this is a model and first the data is like zeros, you feed in the zeros and train for the zeros, the model will think that all of the data is zero. It will be biased towards the zero. And then when all of the zeros are labeled, now comes the one. If I'm talking about if the data is sorted. So now comes the one. And then after 1000 iterations of the one, the model will think that all of the data is just one, and it will forget about the zero and get biased towards the one. And all the way when you're done, almost done labeling the data, when you come to 9, the model will think that all of the data is actually a 9. It will forget the the digits and the data below, and it will be biased towards the 9. So the problem here, the problem, this is the problem, the data will be biased. That's why what the machine learning model does in like normal circumstances is that we tend to like shuffle the data. Yeah, that's the word. So we shuffle the data so that the model gets the zeros, the nines, the eights, the sevens, like all in a random order, so that the model generalizes well over the whole entire, like all of the classes. So the model gets each one of each, uh, more or less equally. So you might think that that as the model is being trained one by one, well, it actually is trained by one, with one images at a time normally. Um, what uh, so when we like, if we want to make it work for the MNIST dataset, what I will do is that when we click the button to load the folder, it will load the folder which contains all of the images of this training model, which means all of the zeros, the ones, the twos, all the way up to the nines in one folder. Then before showing it to the user, what I'll do is randomize and shuffle it so that the user himself doesn't get all of the similar classes at the same time. He gets randomly, and then he can make the labels, and the model will also get it similarly, like the random instances. That's what I'm trying to make. But before that, the challenges are normally to make the model architecture, and then train the model, the training of the model. Okay, so as we can see, the training of the model is done with using these two steps only. So we don't need actual epochs. We just need I forgot something about the batch size. See, because um okay, here I'll see where the batch size is given. Batch. Okay, so it says that the batch size is 4. So in the here, when the data loader is loaded, so it has the batch size of 4, meaning that each of the chunks of data that you get from this data loader will have 4 samples of data. Okay, let's see where else it is used. Okay, as you can see here, that it gets 4 data, and it takes the loss here, the loss function, together with the so as I was saying, they take it together. So it's, as the batch size is 4, when you get the dummy outputs of this is okay, whatever. Hmm. It's a batch of training data from the data loader. Okay. So we also will have an option to select the batch, which will be something like if the user selects that the batch size is 5, then the model will only be trained after the user um, labels 5 images. So there will be a memory or a variable where the 5 labels will be stored, and when the fifth image is labeled, the stored label will be then went go into the model and be trained and shown. The result will be shown at that specific time. Model and be trained and shown. Okay. So okay. So what do we need to do now? These are all the features, so we should not exactly think about these. Not the usage now. Uh, main to do, not to do. It's to do. That should be a very small. No, no, no. I don't want Copilot helping me here. So disable for Markdown. Okay. So hmm. Create model architecture from the model config. Hmm. Create PyTorch training function for one epoch, one batch. Let's say that we can select the batch size, meaning that we need to change something like allow the user to select batch size. Is there any batch size? No, 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 here. Okay, no. Uh, to select batch size. Training function invoke while training function of when label. Yep, these are the thing. This should be 1, 2, 3, 4, 5 features. Main to do. Okay, great. You know what the hardest thing would be here? The hardest thing would be to design the UI. I don't like designing anything. I should go here. Go to this pull request. It was 3 days ago. It's a like comparatively a very good design, considering I don't do designs, and there are specific things that that is what the GUI freezes. That's an important thing that we should be fixing. Mm-hmm. Let's you just select the model. The model is just one. Consider okay, no, it's not one because we spare some different models. Um, let's see select what output. Will be merging this new show loading progress bar, but not loading progress bar to show the video is being created. Shouldn't be like it's not a progress bar actually. Just a loading icon. Show the video is being created. If not, when you open and it will put this. Yeah, this one is GUI.py, not UI.py. No, it has the UI.py and the GUI.py, the GUI. So. Okay. Still not enough green dots. Wait a minute. And I have a call. And I'm back. Sorry for that. All right. Okay. Let's get to working with it. Okay, it's almost 1 hour. Okay, now the PyTorch is downloaded. Not sure if I need the torch vision. Where do we need the torch vision? Let's see. Uh, Here it said the torch vision. We need the transforms. Where to call to normalize to tensor. Tensor compose normal to normalize images and where to get the training data set. So we don't need torch vision, do we? Okay. Okay, requirement already satisfied. That is good. Okay. uh. um, let's go through the model architecture as we'll be working on this create a model architecture on the model config file. So here's the model architecture, which is actually a good thing that because that's a class and we can import a class like this into our main app. That is, that's not the question that I have. Is that when this is pressed, the label is pressed, show image info. No, it's the label image. It says that there's written the labels are given here. So here the model will go in, right? The model will be made in here. The model will be constructed in here when the label page is given here. The model will create the model. Show label frame. Okay. Okay, so here is the model. Let's write it. Create a PyTorch ANN model by reading the JSON file for the number of neurons in each layer. Python ANN model class. Let's see what it gives me. Let's accept this. There's also a forward function. Let's see. Yeah, there's a forward function. Right. So it tells to open the JSON file and it has the layers. Okay. So it opens everything as the layers or just ANN. Okay, let's just say it's the layers. Module list. I'm not sure what it is. Self.layers. It's not the same. Module list. There should be these things and there should be a forward function. Okay, this complicates things a lot. This complicates things a lot because you see that the model created is dynamic. Here. The model created here is dynamic, so that's why I need to ask what this does. New chat. What is going on here? What's going on here? Okay, this line is creating an instance of the module list class from the PyTorch library, assigning it to the self.layers attribute with current module list class in Python that hosts submodules in a list. It is used to store a list of NN model objects, which are building blocks of the neural networks of Python. Example of how to use it. Range number of layers. NN.module. Okay, so we are appending layers to make a specific, and then we take the layers from the layer, blah, blah, blah. Okay, got it. So it's not exactly a layer, it's just I don't know what to call it. What did I call it here? Let's call the same thing. Mm-hmm. Dumping here, and it's taken. Oops. Load. It's not loading here. It's not loading. Excuse me. Let's see how the linear layers are constructed. Linear layers are constructed this and this, right? Just that. Number of inputs of the linear layer, the number of outputs going to. Is it? Yeah, because this is what's coming out. There should be 120 and 120 to 84. Right. Okay. Here should be the input. Should be the output, and that should be the input of the next layer. Write the config here for the AI to understand it better. Okay, so here is the config for the hidden layers and everything. And what I'm going to do is to remove this and allow this. This to be input. Okay. Clever, clever. Okay. Right, because the activation here is not given, right? The config here is also not loaded. So let me just quickly remove this and remove this. And here is what I want. But it should be dynamic, right? Should it be dynamic? This is what I wanted to know, understood, and that's it. That's actually it. It's nothing else. So this is what I wanted to see, I wanted you to understand is that we talk about three layers. We talk about three layers. Input layer, the output layer, the hidden layer, input hidden, and the output. What am I writing? Output. Right. But the input layer is fixed according to the input layer is not trained. The input layer is just the input from the what is given. from the image or the data, whatever you're talking about. So in our case, the particular pixels that's given. The hidden layer is what is trained, or more specifically, these specific nodes, these specific weights are trained. So there are like these are a bunch of weights, and we have got a second set of weights. So there's two sets of weights that we need to train. So that's why it's just like, these are the weights that connects the input layer to the hidden layer, and these are the weights that connects the hidden layer to the output layer. That's what I'm trying to say. That's all. So let's just move this, and let's say that it's this is just copy this and config, and let's cut this. Okay, and now for a variable, this is a fixed one. This is fixed. Let's say that if hidden layer is more than one, then we'll append, keep it pending. And lastly, append the last layer using the -1 here, because that's the problem, because we don't know like how much. We do know, because if we get the length and that put it here, that's also one way to do it. But the smart way to do it is using the -1 to indicate that we are actually looking for the last item on this list. So we get the last one and then connect those units to the output layers units. Right, and lastly, the activation for the softmax final activation function. Sorry, the final activation loss function. Sorry, this is the activation. Right. Right. So we should also the action now. Trying to select augmentation, resizing options. I didn't write the activation. Activation function choose. Yes, right. As for this, not sure if it will work at all. As for the activation here and here, I think for multi-class activation, it should always be a softmax. That's the best. Here, most of the time, I've used the ReLU, that's the linear rectified linear unit. Yeah, the rectified linear unit. But this should also be chosen by the training function, invoke when labeling, option to select batch size, and option to select the activation function, right? So we should actually use to select the activation function. We are now it's getting very messy because then we don't have a specific UI design. But let's see. We have the settings page has the ability to select the channels. The width, the hidden nodes. Mhm. Prelude. Okay. Another thing here in the models, we give nn dot prelude. Sure, why not? So let's see. Next button. We already have that. No, okay. Um, um, that should be one, yes. But okay, no, 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 no. Wait. Uh, hold your horses. Option to choose activation function for hidden layer. Activation label, there should be a label. There should be activity in the grid. Should be a combo 10H current 0 nothing. What the hell is that? Act to choose loss function. Loss function? Seriously, should we choose the loss function? This is getting out of hand now. Okay, let's try it. Yes, so you can see we can choose, but it's not actually working here. Here we are using the units to get, okay. Now to specify the activation, this activation would get. Now it will change the activation according to what we actually use. We'll get here, there's ReLU and everything. We go to label and it's ReLU now. Clean and simple. It's ReLU here. As you can see, I think, yeah, you can see. Now, now, so the ending of this is something that's debatable. This is something that I do not want to. No, I do not want to do it like this. I need to check what activation there is. So if okay, then we produce the ReLU, LF is sigmoid, it's 10H, select 10H, anything else? No. Yep, that's what I wanted to do, because there will always be there. The same goes in here. Should be like this, right? And lastly, if there's nothing on the activation of this last layer, if no, not like this. Activation equals nothing, nothing. There should be. Come on. No, it's not pass. Self.les append sigma. Append sigmoid. That's all. I'm not sure this is the best way to do it. Not particularly sure what's the best way to do it, because it's actually supports these three different types of activation functions, and it's not exactly doing anything else, because if you go here and here, you can write something else. You can write something else. Uh, in that case, I should also give something like, so if it's ReLU, it will be ReLU. If it's sigmoid, or if it's sigmoid, it will be sigmoid. Like it should be like this. Let's remove this, or just let's just call. Oh, let's remove this. ReLU is the most effective, like most used, right? So if it's sigmoid, then it should be sigmoid. If it's tanh, it's tanh. Else for all other, no, for all other things, it will be ReLU, because you always need an activation function. I think most of the cases, you always need an activation function. Mm-hmm. Need to remove these as well. Anyways, right. Mm-hmm. Now, it thing is here, all of the models can be in one specific model, big model file. All of the different types of models. I can also make different files for different models. That can also be it, but there will be different JSON files for different models. Meaning I should keep all the models here. So I should rename this model as models. Right. Okay. Okay, I'm back. So the model architecture is ready here. So there are like two options, two way that we can go right now. Firstly, there should be the model here, the model on the main app that's running, the main thing that's running. The model eventually it should be here actually, because if we call if we construct a class here and the class construct a model in itself, basically it's here, but it's not. The code is not actually in here, but rather on another class. So what can be done is we can initialize a model here after here after the load page show label uh, thing is pressed, because here in this page, when we press the show label controller.label page, we go to the label page. Okay, we go to the label page, and this calls the show label function after doing some like writing it to the config file. It calls the show label frame method. So in this show label frame method, we can construct the actual model. Okay, so let's create the model here. Model equals to ann.model. Yeah. Okay. So this model is actually giving the source file as its input. The question is, do we want that? Here it's getting the source file. Okay, I think we want that. Let's go to the app and import the model. Right, okay. Now, get ready for the errors. Yep, okay. So it took a while to start. Did you see? It took a while to start. Now it's getting a bit overwhelmed. I didn't even create the model yet. Let's see. This function is not yet called. Rather, it's taking some time to run. That is mostly because I'm importing the ANN model, which is actually importing the torch libraries and stuff. Let's not import this. Let's see if it's faster. You see, what a funny thing came into my mind. This is the time that a thought came into my mind to switch from Python to C or C++ at this specific moment, because you see the delay of 2 or 3 seconds before my app starts. This will not happen if I code it in C++, because that's a very system level language, and Python is a very high level language. So yeah, that's the problem. But I want to make it work, and in the future maybe I may like change the code into, because change the code into C++, or use C++ libraries, or using Python or whatever, and I'll find some ways to make the code more faster. But at the moment, I just want this to work. Done, exited with running. 19 seconds. Okay, right. Let's make the model running, and it ran, starting, and let's. do this, and it's not exactly showing me anything, but I'm not exactly sure. Again, the model is being loaded. What can be done is we can show that the model is loading. I'm not sure. I can print in the console, like print the model, maybe. Yeah, that can also work. Okay, the model is not being printed, and now the model is being printed. As you can see, the model list consists of a linear in features of input this many input nodes, and the output nodes is 100 as specified. There's a bias, I don't know what that is. The second node has the inputs of 100 and the output features as 1, as specified, and it has a sigmoid at the end. That's all. That is all. Another thing that confuses me, that where are the right? Interesting. It didn't have really, because this is okay. Yeah, got it. I see the problem now. Here it should be. The capitalization is the problem. Sigmoid tan h. Sigmoid ReLU sigmoid tan h. ReLU sigmoid tan h. Yeah. Sure. It's taking a hefty amount of time. Now you can see the ReLU and the sigmoid function. Right. Just use it like this. Oopsie. Yep. It should not be sigmoid in any case. It's just ReLU and stuff. The activation function is never sigmoid in the middle layers, just tan h or whatever. Okay, I'm just going to, yeah. Yeah, because sigmoids are normally used at the end, like here. Okay, so we created the model. Create PyTorch training function for one batch. Interesting. Again, what to do with the model? Let's see that I can say that self.model equals no. It's a none at first, and then the self.model should be here. Right. We have problems. Okay, now for the label frame, which will actually train the model. Which will actually here will train the model. As this is now in the self, and the show label is created the model in the self can be access to using here because I've already thrown in the self and the parent or whatever. And now the controller is the self until we get the shared data from the controller. What? Yeah. This is the shared data. This is the model. This is the controller. Container. This is the container. Container is thrown in as the parent. Okay, whatever. I'm not sure where is this used. It's not used at all. If we wanted to use, okay, never mind. Okay, and we are now model equals to controller.model. Yeah. First that's none, but then you have the model. Now you have the model. You can go this forward function. Not sure if the forward function cross entropy loss, whatever. This is the loss. This is the loss function. Okay, we have the loss, the optimizer. Model. Okay, this is the model classifier. So if I throw something in the model, then it's going to catch that if it is, it's going to perform the forward function inevitably. Interesting. So I don't have to write that model.forward and give it an X, right? Yeah. Should be the outputs. So show current image, show previous image, load image, label image. This labels the image. No. Let's just say that the batch size is 1. So model.forward. Now it's calling the forward function. Problem here is that there's a resize going on and this pre-processing of the images are going on this in here, but it's not, because in the self list it's just the path string of the image, not the image itself. So what I want to do is write the X as yes, and then we need to resize it. This should not be the thing anyways. Image.tk.photo image. Do we need that? No, we don't need that actually. We need to open the image, and as this is a neural network, like a ANN model, then we need to, like, make it uh I don't know what it's called, like, forgot the name. MNIST ANN PyTorch. Handwritten digit recognition, so that size. It's loading the data, showing the data, building the network. It's the convolution without convolution. I don't want convolution. Simple neural network too. Transform. What is going on in here? The data set, distribution of images, portrait training, while training using the trained data, torturation, the transform, compose, normalize. Yeah, do I need to transform it to the images? Sorry, to tensors. And defining the NN model. Specific thing that I forgot is that custom list, image directory, label name, path, length, get items of population, reshape. Yes, this is what I want to reshape the image. The image is what? The image. I log values. There's an image data frame. Values. Hello, arrow codes. Hello. So I just need to use this actually here. Oh no. This reshape. I'm not sure if the pill image is resizable, right? Reshapeable. That's the word. Also need to transform it into a tensor. Let's ask the AI to do that. Transform the image into tensor. View in chat. Extra transforms, transfer. Okay. For some reason it's here. I need to get it here. Yeah. Where is it? Where was it? So transform the two tensors. Let's see. It was not here. This is the training part. This is the model architecture. So the two things, fine. Then normalize the values between 0 and 1. Clamp. If your tensor is an image tensor created by, it's already in the, oh, it's already in the range of 0 to 1. Okay, you cannot see that, can you? Just move it here. Oh, let's move it. No, that's an awkward position. Let's just keep it here. Is there any way to switch in OBS? Add app, no. Order, no. Transform. Flip vertical, flip vertical. Oh, no, no, whoa. Transform, flip vertical. Transform, flip horizontal. It will look odd, but let's just keep it here. Okay, it's already in in 0 and 1 with transforms or 2 tensor converts the pale image to a numpy nd array and the range of 0 to 255 to a float tensor of shape this the range of 0 to still to ensure. No, okay, I don't want to ensure. I believe here. I believe this. Okay, so it's already in this range. I wish I could see it. I need to, like, um, print it out. I'm not sure. You know what, let's print it out. Sort of shape. Yeah, let's just see the shape. The label image will be called when we label the image. Yeah, right. Save this. Let's turn on the app. It still takes time. Okay, let's just test it with the one note. Let's go to the label and let's see. We'll see the. Okay, so this is the model architecture here below. Yeah, the architecture is fine, and it's not training because I commented here the output here. It's commented. It's not going forward into the through the model and just seeing the shape. Let's see if I need to load the image. So using the MNIST dataset, and let's say that this is just, let's take 0, folder 0, and there are the zeros everywhere. It's not being trained. In the past, I've implemented the keyboard thing that you can use the keyboard to, like, go move around. Anyways, so this is a 0 and I want to label it as 0, and if I press it, and it's going to show me the torch size of 28 by 28 bit. Okay. Yeah. Okay, so what was I thinking actually? Yeah, it's a torch. That's what I was looking for. This is hi, I'm from Bangladesh, but I am actually living in Germany doing my master's. I am from Bangladesh, but doing it in Germany. Okay, you. Okay. So so we can see that this works. So we can see that it's already transformed the image to a tensor. That's fine. Next question, if it resizes, oh, like if it, sorry, if it's what do you call that? normalizes the values between 0 and 1. That's what I want to see. Let's just print whole x. It's going to be a mess, but let's try it. Let's see. Just want to see the values, that's all. Okay, so yeah, I don't care about the model size, so let's select this folder, load up the image, and let's wait. Okay, yeah, as you can see that the values are normalized between 0 and 1. There's no value which is more than 1. It is always normalized. You can see the value of 1 here, rather, because that's the like highest value between 0 and 255, and that was 255. Okay, you too, error codes. So yeah, so that normalizes the thing. Okay, next is unsqueeze. See, okay, this is a lot. X shape is what I wanted to see. Load image, this is the image, and 1, 1. Okay. No, I don't want like this. So I'm not sure if I want the unsqueeze, because the unsqueeze is making another dimension, like putting it inside of another array and creating the dimension. It's good for making batches, but as we are not doing batches right now, maybe tomorrow, so we will not squeeze the image, unsqueeze. Rather, we will. Is it how we change the values? I've just seen it here. Where is it? This is changing, then transforming the self.transform. Transform, poster, transform, self.transform. Transforming my image into what? It's weird. Okay. Right. Yeah. Reshape. Make it in shape 1, 28 times 28. View. Okay, yeah, view is view it is 1, 28 times 28. Okay, let me see the yeah, right. Okay, now I want to move forward in the model. This is what I want to change. Move forward the X. I'm not sure if it's going to have something. Because it's confusing. the gradients are not set. The gradients are not set on everything. The model has. Let me see here. Eval. Okay. That's making the model with an evaluation mode or something. Not sure. Let's see. Okay. Now throws an error. Of course, because these two shapes cannot be multiplied. The model shape I gave was not appropriate. So I'll just go to settings and then change the model shape to 28 by 28, and the output nodes being 1. That's fine. Let's go to the labels. Now it's changed. Okay, and now let's load the images again, and then let's okay, now it worked. Beautiful. Now it worked. What else? Okay, so it goes forward without any problem. This is for the resizing feature. This is for the batching. Yeah. Training function is also done. Not exactly. Training is not done because yet to find the loss function. Evaluation is only done when I'm seeing it, but I'm not actually seeing it. Self-taught model. Okay, now I need to define loss and optimizer. Define loss function and optimizer. Okay. For torch. Can I not do it in the app? Alright. As element, torch vision, transform. Do I need that? The question is, do I need the model here? We can just get the model there. I don't think without any problem, because everything else about the model is being on the label frame py, right? The losses and the criterions, and the criterion is the loss function, not the loss is the loss function. Let's see. The model, the loss function is the nn.cross entropy. It's called the criterion. I don't know why it's called the criterion. Anyways, nn.cross entropy and the Adam loss optimizer learning rate. Okay. That's that. Next part is actually when it's funny because we don't have the y yet. The y is the nodes that's being written. That's it. Let's just say y equals switch to tensor node. Do I need to change anything in the y? No. Okay. That should be the self-optimizer 0 grad. Anything else? No. No. It's more complicated than it needs to be. Anyways. Loss equals self-criterion. Loss backwards. Self-adopting step. Okay, now that's hallucinating right now. Okay, now I need to see a few things. Output y, output the lost of item. That's all I want to see. But I'm thinking at the moment if the model should optimize correctly. Something else that I'm thinking about. Taking a while. Anyways, it's 28. go to label, load up image, and okay, you see the loss as 0. Loss that item is 0. Trust the tensor is 0. Huh? Cross entropy doesn't produce any loss. It's not producing any loss. Is it normal? Not sure. Still not showing any losses. Is it because using the sigmoid loss? Let's change a few things. Let's have it 10 nodes and it's 28, 28 and RealU is fine. And let's go to label and load image. I'm interested in it here. Let's give it, there's the loss that I'm seeing right now. And it's not a, don't think this as a batch. This is just the output of the 10 neurons. It's not a batch. If it was a batch, it should be like, if it was a batch of 5 images, so it should be a 5 outputs of 10 nodes. Like this is the 10 values of the 10 nodes. The loss, however, you see the tensor here is, this is just 10. This is 0. That's the problem. If it's variable, then it should also, the loss should also be the y here. It should also be variable. The y should also be the same shape as the loss that's being generated. Because what we're trying to achieve, if it's a 0, it should be 1 on the 0th, like it's a one hot encoding, should be 1 in the 0th position and 0 in all of the rest. Let's see if I can get the shape of the last layer. The shape of the last layer. Output layer, the shape equals out features. see. Print. Let's try to see this. Mm-hmm. Sigmoid has object has no attribute out features. Let's say here. Mm-hmm. Now it has the 4. It's getting messy, but promise I'll take care of it. Right, to change it into a one-hot encoding of one-hot encoding according to the shape of the last layer. That might work. Tensor dot not okay. With this at that specific position, we have 1. Yeah, that's that. Okay, great. Now I'm expecting to see some loss. Uh-huh. So it's 28, that's 10, and label load images. Okay, thing. There's the loss. There's the loss again. There's the loss again. Great. Great. This is actually good progress. Why do we need CSV again? This will not be needed. I am allowing the user to choose the activation. Training function is invoked while labeling. Option to select the batch size, not yet done. Create Python training function for one batch. Okay, good. Next thing that I want to do is make show the loss and mother model info and UI. Great, let's commit everything. Updated. Training. The label button. Wait, right. Okay, that I think that's it for today. You guys are free to get in here, like get in this repo. It's on the description as well, and contribute if you like and find issues. And I believe that the problem is simple enough to understand. It's not that complicated. So you can solve any of the things on maybe propose a GUI design because I suck at that. Um, so yeah, so that's it for today. I if I have time, I think I will also stream tomorrow. I'm not sure, no promises. And I'll see you in the next one then.